I've updated the scene from the last video, so we now have rotating entities. We have 20,000 of them. Here's the scene name, and we're running it somewhere around 20 frames per second. If I run this the traditional way with game objects, we get a little more than 10 frames per second. The difference isn't that great, but I'm going to explain why later and how you can achieve 100 frames per second, so don't worry about it. Before I move on, let me show you the package manager. Obviously, you need the entities package, but I realized that some people are getting an error message here. That is because you're not checking the dependencies, especially for packages that are related to dots. A lot of them are experimental and are being updated pretty often. So you want to make sure that these versions and the ones you have installed match. There's forward compatibility here, so it's working for me right now. But just make sure you go here, see the different versions, and make sure that the dependencies are matching. Now, the more important part, I'm going to go to the code, something called rotation system. This is a little script that I wrote and inherits from the component system. It rotates entities 180 degrees per second. This is comparable to my other code, the rotator. And this you should already be familiar with. We have the mono behavior. We have a reference to transform, rotate on the y-axis 180 degrees per second. This script is attached to the cube game object, and there's nothing much to say here. You can just download this project in the links below. So let me just go back. First, you have to understand that in ECS, data and behavior are completely separated. Like I said in my last video, all data like position or rotation are organized in a way that you can iterate through them really quickly. Or if you have a certain ID or a key from an entity, you can iterate through a certain set of data really quickly. So here I am overriding a function called onUpdate. This script is not attached to a game object or anything. It's just sitting in my project folder. We don't have access to know exactly how this function gets called, but just make sure that you're inheriting from the component system, and this gets called every single frame. In most cases, you don't have to worry about it, but here, if you don't know what a lambda expression is, this might be really confusing. First, make sure that you check out the C# documentation on this operator. This is just a function written in a different way. Let me put it here. Separate it for now. Think of this as an ordinary function. It just doesn't have a name. And on the left side of the arrow, we have the parameter. And on the right side, we have the definition of the actual function. Here, we're simply getting a rotation on the y-axis. Quaternion with a small q is just a struct used in ECS. Make sure you read the documentation so that you don't get confused with this Quaternion versus this Quaternion. The big difference here is that this Quaternion uses radians. So for 180 degrees, you just got converted. So once we get the rotation that we want, we multiply it to the current rotation. This is a matrix multiplication, and it might be a little confusing why we're multiplying, not adding. I suggest you check out this video. I think it's one of the better ones that tries to explain more intuitively. When you're multiplying quaternions, which are matrices representing angles, you're adding angles. So from the current angle, we're adding the angle that we want. Now if you look at this whole function as just a variable, we're passing it on to this function. This means that we're getting every entity that has the rotation value, get the rotation, and run it through this function. So this is just a quick way to change every rotation data for every entity. Let me just put it back. So if I go back and play, the ECS is probably going to be faster than running through all of the game objects. If I look at the old update function, again, we don't have access to the exact code, but Unity has an internal data structure that lets you know which scripts use the update or not use the update. Usually we check the game objects, go through the components, go through references and abstracts and virtuals, and eventually we get to the data that we want. You're jumping from memory to memory, whereas in ECS, the emphasis is on how you organize the data so you can run right through them. When you're updating a lot of data in the same frame, ECS by design is going to be faster. But it's not exactly jaw-dropping because we're still running this on a single thread, which means we're still going through thousands and thousands of entities, changing their data one by one. And that's where the job system comes in, because if you can update multiple things at the same time, you get multiples more speed. You're probably going to get the best performance if you use ECS and the job system. And I think that's what I'm going to do in the next video. So that's it for this one. Thanks for watching. I have all the links below, and I'll see you next time.